questions that I asked you to do for practice. Let's go through those. We're going to use the 5-part problem solving method. So we're going to calculate average speed. So what we don't know, we'll write down here. Remember, we need to write down, figure out what each number is when we come to it while we're reading the problem so we don't feel overwhelmed. So calculate the average speed, so I put that in there, of an ostrich that runs 1,000 meters, so that's a distance, equals 1,000 meters in 12 seconds, and that is a time. And the formula that we're going to use, it has S, D, and T in it. Well, S equals D over T. Let's plug into that formula over here in the work column. So we have 1,000 meters divided by 12 equals S. And when we do out that math, we end up with 83.33 meters per second. Now notice I didn't put a bar over this number because I hate the bar. The bar is something that you use with in math because they care about the 73rd place. I don't care about that. Round appropriately to non-zero numbers after the decimal point. Okay, let's go to the next problem. So average speed equals, that's what we're looking for, of Mario, who runs up the 4-meter ramp, so that's a distance, equals 4 meters up. Just get in the habit of writing down directions if they give it to you. To save Princess Peach, it takes him 12 seconds. A lot of 12s on this paper. 12 seconds is the time. So we're looking for a formula that has S, D, and T in it. And hey, look, whoops, there's one right there. So we got S equals D over T. Let's plug into that formula. S equals 4 divided by 12. And that looks like about a third to me, so 0.33 meters per second. And because we're asked for speed, we don't necessarily need to put the direction on that because it's a speed. If it was asking for velocity, then you would have to put that up on there. Okay, so next one says calculate the distance in meters that Mario runs if he maintains this average speed. So the speed is 0.33 meters per second. We're looking for distance, so we'll write that in there. And then for 1 minute, in 1 minute, because our unit here is in seconds, we need to convert 1 minute into seconds, so the time is 60 seconds. So again, we're looking for a formula that has S, D, and T in it. So S equals D over T. Plug into that formula, 0.33 equals distance divided by 60. Doing that crazy Bolvin math here, where we're going to put a 1 underneath here, doesn't change this side. And we're going to multiply these two things together, so that's just D, and set them equal to those two things together. And when you do the math out, you find out that it's 19.8. Now, we're looking for a distance, so what's the unit going to be? Well, we're looking at your speed unit. The distance part of that is meters, so that would be what you have. Okay? So that takes care of the speed problems. Flipping the paper over, let's make sure that you're in the screen here. Calculate the acceleration. So now we're going to use a different formula. We're looking for acceleration of a car in meters per second that can go from rest to 45 meters. So the change in velocity is 45 meters per second because it went from rest. If you were starting from 30 meters per second going to 45, the change in velocity would be 15. But most of the time I'm going to ask you to start from rest. So the change in velocity is going to be what the velocity is. And it doesn't give us a direction in this one, so we're all set there. And the time equals 10 seconds. So now we need a formula that has A, V, and T in it. And if you flip the paper over, you see that A equals V, or change in V, divided by t. So let's plug into that formula. A equals 45 divided by 10. So the answer is 40, the speed, the acceleration that we're looking for is 4.5 meters per second squared, because this is the unit for acceleration. Okay, so that first acceleration problem, all right, whoops, sorry about that. Second one, calculate the instantaneous speed. So we're looking for speed, but we also know that speed is the same as velocity, so that may help us. At the 10-second mark, so that's the time of a bicycle that accelerates, and it gives us the acceleration here, 2 meters per second squared. So the formula that we have is A equals V divided by t. And because we know v and s are the same, except for velocity has a direction, we can still use that. So let's plug into this formula. We got 2 equals the velocity or the speed, whichever one you want to use, divided by 10. We're going to do some of that like magical Bovin math here, and we're going to cross multiply. So we got 2 times 10 equals v, and we know that v is the same as s. So the speed is going to be 20 meters per second, because we're looking for a speed. The last one that's on this page, calculate the speed. So again, we're looking for speed, and we know the speed and velocity are the same thing. Who accelerates from rest for 3 seconds, so that's our time, 3 seconds, while he goes down a ramp, so whatever direction we have here is going to be down, a ramp with an acceleration of 5 meters per second squared, and that's going to be down as well. Okay, so the formula, A equals v over t, knowing that v and s are the same thing. So we have 5 equals v divided by 3. So we got v equals, doing that crazy Bovin math, we have v equals 3 times 5, because v times 1 is equal to this, so that's 15. Now I'm going to show you a little tricksy thing. We'll put the answer in here. Meters per second, and we actually know the direction here. So even though it's a speed, sometimes if you don't know if you should put a direction on there, throw it on there, because you won't lose anything by putting it on there. But if you don't have it and you need it, you will lose a point. There's another formula here that might actually be a little bit more help. It's just kind of rearranging this formula. And I'm going to do it right down here so you can see how I get it. So if we want to get v by itself, or s, same thing, we're going to multiply both sides by t. And by doing that, because it's really t over 1, this t cancels out with this t. So you get something that looks like this, v equals at. That's the VAT formula. V equals at. A lot of kids use that one because it's a lot easier to remember, because it's actually a word. And guess what? If we're talking about speed, it's not the VAT formula, it's the SAT formula. Still easy to remember. So that I didn't give you this one on your formula sheet, but you can, if you remember that, because you use it a lot, it's a lot easier if you're looking for speed or velocity directly. That will give it to you. Okay, well, that's it for this worksheet. Thanks for joining me. Have a good day.